Good morning, one and all. We are Team Mithuna from MVGR College of Engineering, Team ID, Team 19. Today I am gonna explain about our project Agro Twin. Agro Twin, actually, in this particular era of digital revolution, the technology has been evolved so much that even farming also requires some IoT or technological innovations which reduces the labor cost and increases technology usage. What is AgroTwin? AgroTwin, agro means agriculture and twin means digital twin. We are incorporating digital twin technology in agriculture. First of all, what do you mean by digital twin technology? In digital twin technology is nothing but replicating a physical entity into a digital one through which we can prevent diseases not by we can identify diseases in crops and plants not by directly manually checking each crop in an acre of land. First of all, our idea of digital twin, we got into we are this topic in our second year of engineering, where we had attended a course of digital twin in IIIT Sri City, where we got exposed towards what is the digital twin technology and how is it being used in the particular industry 5.0. In this particular technology, we use a physical entity and replicate it into digitally, so that in this particular of time each and everything is maintained after or any damage occurs, then only they are taking the corrective measures. But using digital twin, we can have preventive measures in which before the damage is being occurred, we can prevent it or predict it. We can predict it before the damage being occurred. So our topic is Agro Twin will take a 1 acre of land in which we take a portion which is divided into 10 by 10 grids of boxes. Total 100 slots will be available in that, and we will be identifying the defective crops in that particular 100 slots. As our project is completely dependent on physical work, and this ideathon or hackathon which we are participating is completely digital one. We are trying to replicate how the physical thing is being going on into a digital one. So let's see what are the technologies which we are being using in our project. First one is digital twin technology, as we discussed before, and AI powered analysis, in which at the end we'll be deploying a chatbot through which a farmer could directly interact with the website or the interface, through which he can know about how his farm is going to be cultivated or how the yield is being produced in this particular of time through AI powered analysis. 3D field simulation. In 3D field simulation, we will be simulating how the physical thing which we are planning to do is simulated into a 3D kind of model in our interface. Crop configuration. We had configured our crops in two different types. One is healthy and another one is unhealthy. Healthy crops are marked as green color, and unhealthy crops or diseased crops are marked as red color. Real-time processing. As we use ML algorithms and real-time, we are taking feedback from the real-time sources. We use NVIDIA Jetson board, in which it provides edge computing, which can be which is not incorporated with any cloud server or any kind of thing. The data is being collected, processed and actuated in that particular of time in real time. Expert consultation, and at the end AI would assist us how to take the preventive measures in our crops, so that our yield would be increased or any kind of thing. Okay, let's get started. Okay, as we can see, we have taken a 10 by 10 grid over here. In this 10 by 10 grid, let us consider 1 acre of land in which we have taken a portion which is being divided into 10 rows and 10 columns, total of 100 slots. In this we pick 15 slots. Click on, as we can see a prompt here, click on the grid cells to select 15 spots that will be infected in the simulation. These spots will represent areas with crop diseases that need to be identified and treated. We request our jury members to pick 15 slots randomly from this particular 100 slotted grid, so that picked 15 slots are identified as infected places and the remaining 85 slots would be healthy crops. Let us try to simulate how is it going to be. Let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are the 15 slots which I picked. All these green color marked ones are healthy crops and the red color marked ones are the diseased crops or the infected crops. As we can see the progress, we have picked 15 out of 15 slots. Now we'll save this configuration and we'll start simulating it in 3D. Yeah, as we can see, this is how our 3D simulated model would be looking like, in which this blue color one which we are seeing over here is the bot which we designed physically, which moves around the field and detects whether the crop is healthy or unhealthy. And all these slots which we are seeing here are the grids or the plants which are present in that particular area. As we can see an instruction clearly, like we can use WSAD or WSAD for movement and space for selecting the particular crop. By using WSAD, we can move our board to left, to right, downwards or upwards. This is how our process is going to be. Let us first check this particular crop, in which after reaching that particular crop, to scan how the crop health is being, like whether is it healthy or not, we need to click spacebar. After clicking spacebar, we can clearly see that this particular crop is healthy. And one more thing which I would like to add is, the bot which is moving now doesn't know or doesn't have any idea where the infected crops are, right? So the bot is not pre-trained with any particular data that these are infected crops, these are not infected crops. The bot just moves around the field, checks each and every crop and identifies the unhealthy crops. Okay, as we can see here, it is a rice crop which is healthy and the position is at 5th row and z-axis is 35. Okay, let us check the first one where, yeah, as we can see, before one is healthy crop and this one is the defective crop. This is also rice and these are the positioning coordinates. Yeah, now after we leave from that particular crop, we can see that all the infected crops which we marked are highlighted in red color. And after once we decide this particular crop is infected, we use our chatbot or an AI expert to get the feedback about, or to get the expert assistance for how to treat the crop. Yeah, this is a chatbot which we built using AI, and we have some predefined questions like, see, 90% of the people are interested in this particular question, like what is the problem with this crop, okay, and 80% of the people, is it a serious problem, pesticide selection, what pesticide should I use, like, okay. Let us first take this particular question. As we can see, while clicking over here, we can get the same question over here. These are the most commonly asked questions by farmers, and without any physical intervenence, they just want to know how the yield or how the crop is being cultivated in that particular field. Okay, now let us give this request to the chatbot and let's see how it responds. Takes a few minutes of time. Yeah. Now what the question is what is the problem with this crop? Rice wilt is a serious condition caused by pathogens like these, leading to plant collapse due to vascular blockage. Here's what happening. It gives the complete information about the problem which is associated with that particular of crop. Okay. As we can go through these to get the detailed information about the disease which is being incorporated with the particular crop. And let us see what pesticide should I use. Let's ask the chatbot to whether this is what we get information from this particular of question, like what is the problem with this crop, and now we are seeking help from that particular AI to get information about what pesticide to be used to mitigate this problem. Yeah. For treating rice wilt, consider the following pesticide options. These are the following pesticide options along with their combinations and how much of it must be mixed with water and everything is completely given in this particular field. Okay. Now let's see dosage. What is the current dosage per acre? Let's see. Yeah. All the readings are completely given in this particular of prompt which we had given to this chatbot. And application methods, we have two different types of question. When is the best time to spray, and should I spray on leaves or soil? Like some crops are affected by the soil and some crops are affected by the leaves. As our bot moves over the crops and scans each and everything of the plant and gets a detailed review of what is going on with the plant. So let's see when is the best time to spray. Yeah. As we can see, actionable advice: schedule spraying between 6 a.m. to 8 a.m. or 4 p.m. to 6 p.m. Avoid spraying during middays heat of strong winds. It also suggests us the what time to spray and at what weather conditions do we need to spray. Okay, this is how our chatbot gets interacted. This is how our interactive chatbot interacts with the user and the farm, and advises us the mitigation processes or the mitigation strategies, when to use, how to use, etc. etc. Yeah. Thank you.